So in fact, with the case of Fireship, so we talked about it, how the Fireship exploited. So in fact, the HTTP session hijacking, and with that, which is very clear about when an attacker gets hold of a user cookie, they can do anything in the user can do on a particular website. So this is a very classical example of an unprotected session ID cookie and leaking the session ID cookie. And secure the cookie is an absolutely trivial way for an attacker to the mountain session to hijacking the attack. So let's say deep dive of this. So let's go and take a look of the slide and explain exactly what just went on the session sniping. So here we are a very simple explanation. We have a victim who makes a request to the server passing their session ID. In this case, it doesn't actually matter whether the session ID is persisted by the URL or a virus cookie. The point is that this is a HTTP request. It is not encrypted on the transported layer. So now we have got the attacker sitting down here, and the attacker snips the session ID from the victim. So how do they snip it? It could be a wireless network. So for example, a network in a public place that someone has stood up in order to entice people to connect and snip up their data. And it could be the victim DNS that has been hijacked, and they are actually sending the request to someone else server to be attacked as a server. It could even be that the ISP in the intercepting the traffic, which certainly seen many examples that happened in the past, particularly when there is a government intervention to play as well. So the attacker snips when the session ID and then simply makes a request to themselves with the same ID. That's the simple session snapping and particularly hijacking. Once that ID has been snipped, this is a very simple. Now later on we'll talk about the different way to protect from this sort of attack, and the main thing to understand now is that when the request goes over an unencrypted connection, assume that every piece of data can be observed by the attacker. So now let's give you a demonstration. So attacker loads up a device like this. This is a simple device, and attacker actually set a session ID. In fact, session ID is something like, as an example, end with 764 or something. So effectively the victim now has a session as well, and the victim then where a login to the session, it will attack the unauthorizing state in this session, and then the attacker simply reload the page and send the session ID of the server, and the server came back and said that the session ID of the victim ID identified. And it's a very simple way to attack, and it made all the easier by the fact that the use persistent, like you can use fiddler to get the information of your cookies if this website is not verifiable. So this is a very rudimentary attack. So there are many applications that are risk of session fixation. Now there is a very easy test to see if an application has this risk or you do a begin of a session. so what the session ID is, and then login, and if the session ID doesn't change and the authenticated state is actually persisted by the session ID, there is almost certainly a risk. So keep an eye on what happens to the session ID when a login occurs. That's the main key. So that's a session fixation, and let's now move on and take a look at the actual brute forcing and the session ID. Let's finish this by talking about session donation, and this isn't really a hijacking, but it's a very closely related, and it's a worthwhile being aware of that it involves a bit of social engineering too, so which does makes things a little bit more interesting. So here's what we're going to do. So we're gonna use a virtual machine. So you are as you can see, I am not logged into any of the account or not even registered. So I'm going to register an account, the name of the victim. As an example, I will register as, I'll put the example email address, and I'll put the first name, so I'm going to register an account with the name of the victim, and I'll create an email address, and I will enter the name, and clearly my victim here is John Smith. So his first name, his last name, and with the password of my choosing as an attacker, I'll register. So as you can see, I register with a attacker name, and if John follows this URL and loads it up, and of course John is now will be authenticated as John. And how this actually work? Well, what we have done is that the attacker is given our victim a link, and that includes a session ID, and that has targeted name already logged in it. So when John Smith loads this page, as far as he is concerned, he is logged in because he sees his name. Now this is really the first part of the attack, and it is a bit of social engineering. So we are trying to convince John that this is him, but of course on the face value this would be correct. So this does look like him. This trick is now that we can attacker elicit more information from John. For an example, maybe the attacker would give John a link that goes to the profile page and say, hey John, your profile is out of data, you might like to fill out some your information to complete the account. So the John to fill out some of the further profile details before he can actually perform an action. So for an example, like actually voting on these supercards, it's all about how we can get the attacker to provide information of John's, and with John thinking that this is secure and private, but actually providing the attacker profile simply by tricking the victim into thinking that they are already logged in. So let's go and check out a diagram of this. So what is, just to make this simply clear. So here we go. Let's start with an attacker, and the attacker registers and log into the spoof account. Now again, the spoof account is an account that looks like one should be owned by the victim. And then the attacker gets back to the session ID. For example, they get an URL with the session ID in it, and now it could always be cookie based session persistence, and then the attacker would need to export and execute the access risk to target the site. So in order to give the correct session idea to the victim, the process would actually work either way, but again caveat is that the cookies is needing to be the complete and other risk as well. So attacker gets back to the session ID and then provide it to the victim. So the example we did with session persistent in the URL, we had a URL with the session ID that ended with 765. Now the victim is seeing this page and saying, hey, this looks like I'm logged in, but it's not authenticated to the site based on the fact that the victim is happy to share information with the site because they think they are doing so privately, but it isn't. And one of the beauties of this attack is that so many other controls we put in a place. For example, if we had HTTPS everywhere, the secure transported layer, this still works. You won't get any browser warning, like you might just say cross-site scripting attack, and let's just face it, people used to go on a website and still been logged in for hours and hours. So we have a lot of application out there with a long running session, because it means you can come back to the website and still logged in for the usability. So from a victim's perspective, there is nothing unusual about following a link to a website and saying that they still logged in. Now there's a session donation. Now we didn't really hijack the session in the sense that we took a session ID and the victim already had, but the end result was pretty much the same. We had the attacker in the victim both using the same session ID, and the attacker were able to obtain sensitive information that the victim entered and was logged on that attacker spoof account.